Okay, this is a problem 32, page 519. Last problem of week 11 and last problem of homework set 37. You have a sister problem right next door, 31. And this problem is called solving right triangles. And we just cracked into chapter 8. Chapter 8, I think the setup here is a little bit odd. It's okay, it's a little bit odd in as much as chapter 8 is in large part about solving triangles, any type of triangles. And it's a good thing because what you're going to do here is you're going to really you're going to really upgrade your analytical geometry skills, especially with respect to triangles, by introducing some new trigonometric laws. And we're going to start slow by solving right triangles and build to solving just general acute and obtuse triangles that do not necessarily have a right angle. You're way ahead of the game solving right triangles because you know A, that you have a right angle, and B, this triangle obeys the Pythagorean theorem, a squared plus b squared is equal to c squared. So get used to this formalism where all the angles are called capital A, B, and capital C. The sides across from those angles are small a, small b, and small c. So in this triangle, here's capital letter A for this angle, top angle. The side across from it is little a, and in problem 32, little a is 7, B is 50 degrees. And so let's find everything else. In particular, let's find B and C, the remaining sides, and side A. Let's start right here, and let's just say, given that the sum of all the angles is equal to 180 degrees, I've used up 140, right? Here's 90, here's 50, add it together, you get 140. That means A must be equal to 40 degrees. Okay, so I'm taking care of that job. And now let's go a little bit further. What else can we do? Let's say since the sine of A is the opposite side A all over the hypotenuse, we can find C, because since this is the case, sine of A is the sine of 40 degrees is equal to A is 7 all over C. C is then equal to 7 divided by the sine of 40. So I'm going to pick up my calculator. I'm not going to hope, it's in degrees mode. I know it's rarely in degrees mode, but it is now. So here's 40, there's the sine of 40. Turn that upside down and multiply by 7. And what I get is that C is equal to 10.89. So there's C, 10.89. And so 3, what should we do to get B? A couple of ways we could go with B. We could do that same thing with the sine. Let's do both. Let's start by going using Pythagorean theorem. Since c squared is equal to a squared plus b squared is equal to c squared minus a squared. And if I want to find b, it's just equal to the square root of c squared minus a squared. Do I know all those things? I do. C squared is 10.89 quantity squared minus a squared is 7 squared, 49. So b works out to be, there is 10.89 squared. Here is a 49, subtract. There's a square root. B turns out to be 8.34. So there you go. Equals 8.34. The other way you could have done it is you could have said this is part A. Here comes part B. You could have said, let's do it this way. You could have said the sine of B is equal to B all over C. Okay, that means that B is equal to C sine B. And in our case, that's 7 No, sorry, C was 10.89. Yeah, 10.89 times the sine of B. B was 50 degrees. If I'm actually gonna work it out just to show you that I'm a little paranoid sometimes. There's the 50, here's the sine, multiply by 10.89. I almost can't bear to look. Oh no, sure enough, turns out to be 8.34, one way or the other. All right, very good. Well, see you next week with problem set 38.